Hello, welcome to another edition of James and Chris Science Videos, where today we're going to be looking at evolution and selective breeding, focusing on the mechanics behind evolution and then how us as humans have changed how evolution works by a process called selective breeding, which has been around a long time, about 35,000 years was when we really started to domesticate and selectively breed different animals. So let's start off with this picture here. I've got a Belgian blue cow, which is a very impressive specimen. The story of how we get from bacteria, which is the original, or we think is the original life form, to this blue cow, is a long process that takes millions and millions of years, and was first described by this guy in the bottom left-hand corner called Charles Darwin. Evolution was mentioned before then by scientists like Lamarck and Cuvier. They both use the terms, but the first person to really give a way by which evolution could happen was Charles Darwin. And so to explain this, I'm going to use peppered moths, which are, you can see to the right-hand side, two species of moths, of which the white speckled one is the original species. The black one is a mutation that occasionally occurs within the moth. Now, if we look at this, here is an original picture of a peppered moth and a black mutated moth. I don't know whether you can see, it's really hard to see the peppered moth, but the black moth is really obvious. In fact, if I circle it, there you go, that's the peppered moth there in the purple circle, whereas the black mutant stands out a lot more. Now, birds fly around, and birds like to eat peppered moths. So if you were as a bird and you were flying around, which one of those are you most likely to eat? And the answer is the black one. It stands out more. So the peppered moth, the whiter moth, is more likely to survive. And so over the future, the peppered moth, the whiter one, is going to pass its genes because that's going to live long enough to reproduce, whereas the black one probably won't. Now that mutation occurred for a while, and if there was no change with this and the black peppered moth showed no advantage, eventually the black peppered moth would disappear, would die off, and the white peppered moth would be the dominant species that would continue forward by evolution. But we're finding that the environment occasionally changes, and in this situation the Industrial Revolution made a big change to the bark of trees. Now, the bark that picture has shown you on has got something called lichen on, and lichen is a white coloured that covers trees. Now, as an organism, lichen is very, very susceptible to pollution. So any kind of pollution, lichen dies. And around the time of the Industrial Revolution, we found that lichen suddenly started disappearing off trees, and trees now look like this. And the darker coloured trees became advantageous for the black moth. So all of a sudden, the birds that are flying around thinking, "Ooh, I'm going to eat a moth," which moth is he now going to eat? And it's going to be the white ones. And so over time, the black species becomes prevalent. It becomes the majority, the one that passes down its genes to the offspring rather than peppered moth. And so over time, the white peppered moth has become far less numerous, and eventually over time, if that continued, they would disappear. Now, environmental conditions are better, so we're beginning to see a bit of a resurgence of peppered moths as we're seeing more lichen growing on trees. So it isn't always so obvious. Now, I've circled the black moth in case you can't see it. There he is there. And so this process by which nature selects the survivor, and it's that survivor then passes on its genes, along with occasional mutations, is what evolution, or the process of natural selection, is. So how can we use this? Well, I'm going to explain how we can use this using Mr. Men, and we're going to first of all talk about how genes are passed on, and we're going to look at how we can use that to predict and then manipulate species so that we get traits that we want. So at the bottom here I've got 6 Mr. Men. Hopefully you're fans of Mr. Men and you can recognise them. And then on the right hand side we've got 6 little misses. Now what I'm going to do is going to imagine that they all get together and breed, and we're going to look at their offspring. So let's look at offspring number 1. There it is at the top. Can you guess who the parents are of offspring number 1? I'm going to go to the answers in a second. We'll look at the traits, look at the characteristics, decide who the two parents are. We decided? We'll come back to that in a second. Offspring number 2. There we go, slightly odd looking one. But who would you predict as being the parents of offspring number 2? Look at the characteristics and traits, what have been passed down. Offspring number 3 is there. Again, look at the characteristics and traits. You've guessed it. Offspring number 4 is coming up. There we go. Offspring number 5. You can pause the video if you want more time on these to work out who the parents are. Offspring number 5. Who do you think those parents are? And finally, offspring number 6. So, let's see how you did. Let's see if you got them right. Number 1, well, the parents, we've got a spiky outside and a blue colour and yellow hair, so that must be Mr. Sneeze and Little Miss Sporty. Number 2, we've got the body shape and the hair, but we've got the smile and the colour of Mr. Uppity and Little Miss Chatterbox. So those two have mated in order to form that offspring. Number 3, we've definitely got the pink colour of Mr. Greedy, but we've got the hair and body shape of Little Miss Stubborn. So those would be those parents. The next one would be if we put Mr. Small with Little Miss Tiny, we would get that offspring. Then we're on to, I think that's Little Miss Busy, definitely. The hair's the same. The body shape is similar, but it's definitely got Mr. Nosy's nose. So those are the two parents there. And finally, square shape is Mr. Strong, and definitely with a smile and the freckles would be Little Miss Sunshine. So we can work out by looking at the characteristics who the parents were, and we can say those characteristics have been inherited. They've been passed along from parent to offspring. The process by which that happens is sexual reproduction. The father, the male of the species, will produce sperm, and inside the sperm, each sperm contains half of the father's genes. And that will then meet the ovum from the mum, which contains half of mum's genes. You put them together, the two halves match, and you end up with an offspring. Now, there are some interesting things that come out of this. If I choose a trait, and if both species, or both parents, have that trait, and I mate them, then that trait can become exaggerated. So here's an example of Mr. Small mating with Little Miss Tiny. And you can see both of them are small, but their offspring is even smaller. So if I choose a trait that I want, and I mate two organisms, animals, male and a female together, that both contain that trait, then that trait can become exaggerated. Now, this we've been using for a long period of time. The example I'm going to give is the domestication of wolves, which happened about 35,000 BC. And so we look here, here is a wolf that was tamed by humans, and over time they have selected certain traits and they have bred those traits. So I've put it next to this a really small dog. That's a Mexican Chihuahua, which was bred to be small so that they could go into rat holes to kill the rats. And so they were bred for purpose. Now, to do that, what you have to do is take the smallest wolf, male wolf, and the smallest female wolf and mate them, and then the offspring should be smaller. And if you do that over hundreds and thousands of, well, not hundreds of years, thousands of years, then eventually the trait becomes more and more exaggerated until you end up with a very small dog. The reverse of that, if I mated the biggest examples of the wolves, then eventually we end up with a bigger dog. So here is a St. Bernard, one of my favourite dogs. I love St. Bernards. Massive dog, but that only comes through breeding large wolves with large wolves with large wolves until eventually we get to that size. Now, I want to pause for a second. I want you to think, size is not the only trait that we want. So what other traits do you think we would want to breed in our wolves? And opposite, which traits would you want to breed out? Because some traits we want to get rid of. So I'll give you just a couple of seconds just to think about that. What traits would you like to encourage, and which traits would you like to discourage? So hopefully you've had a think about that. These are the kind of things that I think you should be thinking of. In order to breed our wolves, what we want are wolves that are intelligent. We don't want the really, really dim-witted ones because we want to train them to do jobs. So we're going to look for intelligence. We're going to see the most clever wolves and we're going to breed them. We're going to want them not to be vicious. Although if you're going to breed a guard dog, there's an argument that you might want a level of viciousness. So we want them to be obedient. We want them to be fairly docile. We want them to be trainable. All of those traits we want to then breed. We want to breed healthy animals. If you've got a wolf or a dog that's always sick, you certainly wouldn't be using that to breed your next generation. Now, here is a cow. This is a Frisian cow. It's used in the production of milk. Now, I've given you some example for the wolves. I'm not going to give you any more examples on this. I actually want you to write down and to think about the traits that you would want to breed within Frisian cows. So if you were a farmer and you had a herd of Frisian cows and you were selecting which cows to mate, and then you had a selection of bulls, which bulls would you choose in order to mate? So that's a job for you to do. I want you to think about the different traits needed in order to produce a productive milk farm. So let's summarize. Natural selection is the way in which nature creates new species and how organisms evolve. The idea of natural selection is that nature will kill off some versions and the traits that help them survive are the ones that are passed on to their offspring. Humans, for a long time now, have been able to bypass evolution and select animals to breed and then breed in certain traits. If I want to breed in a trait, then I need to get two examples of that, breed them together, and we can get an exaggerated trait. Farmers use this technique all the time, and not just for animals, for plants too. If you've got a really productive raspberry bush, you'd probably self-pollinate it and you'd use the seeds from that raspberry bush for your next generation. All right, hope you enjoyed today's lesson. Hope to see you again soon. Bye-bye.